We're going to look at a worksheet that I came up with that has some volume with known cross sections problem. All of the cross sections are going to be perpendicular to the x-axis. When we finish this video, you're going to have some delta math problems to work. Okay, so the first problem that we have here is a region bounded by the graph of y equals x squared, x equals 4, and the x-axis. So let's sketch that little graph here. And I know my sketches are probably going to be bad again today. But we have a parabola, y equals x squared. We have x equals 4. And we have the x-axis. So that means that our region is this region right in here. So this is going to be the base of your three-dimensional object that we want to find the volume of that object. So in the first example, the cross sections are perpendicular to the x-axis. As I said, all of these are going to be perpendicular to the x-axis, and they're going to be squares. So if you'll remember from yesterday, one of the first things that I like to do is draw on one of my little slices. And so I'm going to take a different color pen here, and I'm going to draw a little sample slice. So there's my little slice. It's going to go from the point on the parabola to the x-axis. So this is going to be the length S. So in this case, this is a fairly easy problem. The length S is going to be x squared. You can still think of it as the top curve minus the bottom curve, which is x squared minus 0, which is x squared. All right, so we're going to draw a little square over here. So this is going to be our base side, S. And we're going to have our little square. It's S by S. So we know that the area of the square is side squared, which means it's going to be x squared squared, which of course is just x to the 4th. So it should be fairly easy to write our volume integral here. So our volume will be the integral from 0 to 4, because that's the range, the domain of the region, the range of the x's that we have in that base region, 0 to 4. And so it's going to be our area, which is x to the 4th dx. Now this one would be fairly easy to integrate, but that's not the point of our what we're trying to get accomplished today. So let's just keep moving on here. All right, so the next one is cross sections perpendicular to the x-axis are semicircles with a diameter in the base region. So if you recall, that means this is S. This is the base of a semicircle, which means that's actually the diameter. And that means that 1/2 of S is going to be our radius. So our area formula for a semicircle is 1/2 pi r squared, which of course will be 1/2 pi of 1/2 of S squared. Okay, remember yesterday we talked about the fact that you could leave it like that, or you could actually realize that 1/2 squared is 1/4 times 1/2 is 1/8. So I could write my volume as the integral from 0 to 4 of 1/2 of pi times 1/2 of x squared. Remember, x squared is S squared dx. Or I could write it as the integral from 0 to 4 of 1/8 of pi, and then our x squared squared would be x to the 4th with respect to x. So dx is representing our thickness. So area times thickness. Okay, so now what about a quarter circle where the radius is in the base? So this is going to be our little length S. So this means this will also be S, and we're going to have a little quarter circle. So now we know that the area is 1/4, because it's a quarter circle, pi r squared. S is still x squared, as it was earlier. That's not going to change. So that means this volume will be the integral from 0 to 4 of 1/4 pi of S squared, because S is your radius. So that's going to be x squared squared again, or x to the 4th. However you want to write it will be fine. All right, let's look at this next one. This is the last one with that same region. So now we have the cross sections are perpendicular to the x-axis, and we get a rectangle with a height of 2. Now that yesterday we had one that had a height that was 2 times the base. This one is just a height of 2. So that means we're going to have our base S, and I don't know what 2 is in relationship to S, but it's going to be the height, 2. So that means our area is going to be 2S, which is 2x squared, because S is still x squared. So our volume will be the integral from 0 to 4 of 2x squared, because that's our area formula, dx. Okay, let's look at some different examples with some different regions. Okay, we have 2 examples here with this region. We have the region bounded by the parabola y equals x squared minus 1. Okay, that means we have a parabola that's moved vertically shifted down 1. Be like this. And then we have the line y equals x plus 1. So that means it has a y-intercept of 1. It has a slope of 1. I'll go across here like this. And we would need to find, oh, that's really bad. We need to find our points of intersection. So we're going to have x squared minus 1 is equal to x squared plus 1. So that's a quadratic equation. Get myself a little more room here. So we'd have x squared minus x minus 2 equals 0, which is going to factor into x minus 2 times x plus 1 equals 0. And that means we're going to intersect at 2 and negative 1, which means I did a pretty decent job of hitting the negative 1 right there. And this is going to be 2, and let's see, it'll be 2, 3, but that 3 isn't that big a deal. This is negative 1, 0. Okay, so our base region is this region. That means that our slice is going to be top minus bottom. So that's going to be the line x plus 1 minus the parabola, which is x squared minus 1. So that's going to give us the length of our slice, which I didn't draw. Let me draw our little slice here. Let's just pick a sample one right there. So we're going from the line to the parabola. So the linear equation is the top curve. Parabola is the bottom curve. So this is going to give us x minus x squared plus 2, because we have a positive 1 and a negative of a negative 1, which will be another positive 1. It'll be plus 2. So that's the length of our slice. All right, let's look at the cross sections that we want. The first one is equilateral triangle. All right, so this is going to be our slice. And so we're going to have our little equilateral triangle. We need to remember that our formula from yesterday was square root of 3 over 4, side squared. So our volume is going to be the integral from this x-intercept, which is negative 1, to this x-intercept, which is 2, and square root of 3 over 4. And we need our s, which is written down here at the bottom, x minus x squared plus 2, side squared dx. All right. The second one is a rectangle with a height of x plus 2. So that's kind of a different take also. So we have this is our S, and whatever this is that's going to make the rectangle, it's x plus 2. So our area is going to be S times x plus 2. So we'll use the S that we have over here, right here, to build our volume formula. So our volume is again going to be the integral from negative 1 to 2. And we're going to have our area formula, which is S, which is x minus x squared plus 2 times the height. So this is the base, this is the height, that's the area of the rectangle, that's the thickness, that gives us the volume. All right, I think I have 2 more examples. So I thought I'd throw an exponential in. So we'll draw us a little exponential curve here. So you have y equals e to the x, we have y equals 4, and the y-axis. So this is our region. Now, where do they intersect? Oh, let's see. We've got a point of intersection right here. So what is that going to be? So let's see. When is e to the x equal to 4? How do I solve for x? Well, I basically take the natural log of both sides. So this is going to be the natural log of 4. So this is going to be natural log of 4, 4. That's the coordinate there. Of course, this is 0, so that's easy. All right, so let's do a little sample slice. Let's do a little red sample slice. So a little red sample slice. So the top curve is the horizontal line, 4, and the bottom is our exponential. So the length of our little slice S is going to be top curve 4 minus bottom curve, which is e to the x. All right, so let's see what kind of cross sections we're going to have. We have perpendicular to the x-axis is an isosceles right triangle. Oops, I left the right out, sorry. With a leg in the base region. So this is going to be S, this is going to be S, and this is going to be your hypotenuse, okay? So our area of that is basically half of a square. So the area is 1/2 S squared. If you remember from the video yesterday, I showed you how you could fold a square or cut a square into half and actually see that. So here's your square, this is half of it. So that's why the area is 1/2 S squared. So our volume will be the integral from 0 to the natural log of 4. And it's going to be 1/2 of S, which is 4 minus e to the x squared with respect to x. These should be pretty simple at this point. Okay, the next one is perpendicular to the x-axis, or rectangle whose height is twice the base. Okay, so this time this is S. This is going to be 2S. So our area will be 2S squared. And so our volume will be the integral from 0 to the natural log of 4 of 2 times our S, which is 4 minus e to the x squared dx. Okay, I hope this helps you a little bit. This is about everything that you'll have to be able to do except for cross sections perpendicular to the y-axis, and we'll deal with that next week.